Hello everyone, welcome to Brain Blitz Audios. Today in this episode of JEE Main, we'll be looking at previous year questions of mathematics asked in engineering entrance examinations in India. Today we're dealing with the chapter Sets, Relations and Functions, which deals with sets of elements, relations between two sets, and also special relations that we call functions. So questions asked in engineering exams are often the benchmark in terms of toughness. So therefore, this video is devoted to explaining the 5 questions contained within it in some detail. So don't forget to watch the entire episode so that at least one of these questions may be helpful to you when you write your JEE exam later in the year. So this is our first question. The graph of the function y equals fx is symmetrical about the line x equals 2. Then, which of these statements is correct? F of x equals f of minus x, f of 2 plus x equals f of 2 minus x, f of x plus 2 equals f of x minus 2, f of x equals minus f of minus x. So, now in this question, the condition is that the graph of the function y equals fx is symmetrical about the line x equals 2. So suppose we have a graph, and let's consider this is x equals 1 and this is x equals 2. So at x equals 2, you have a line which is parallel to the y-axis, and that line is called x equals 2. So in this question, the question says that the graph of the function y equals fx is symmetrical about the line x equals 2. So that means whatever the graph that we draw on the left-hand side will be similar to the one drawn on the right-hand side. So the graph that is possible is a parabolic graph. So in a parabolic graph at focus x equals 2, the right-hand side and the left-hand side are equal. Now, my drawing doesn't really illustrate it, but then that is how it is represented. So, any element in y equals f of x that is to the right of 2 can be written as 2 plus x on the x-axis. And on the left side of the x-axis, anything that is present on f of x has the x value 2 minus x. So 2 plus x, 2 minus x. So therefore, because of this representation, you can write f of 2 minus x is equal to f of 2 plus x. Because if you look at the graph, if we take the same point on both sides of the graph, and if we take the f of x at that point, then you can write that both the functions are equal because they have the same value put in. So therefore, f of 2 minus x equals f of 2 plus x. This is the correct relation that we need to get. So therefore, option B, f of 2 plus x equals f of 2 minus x, is the right answer. Option A is when you have a function which is even. So in an even function, f of x equals f of minus x. Option D does not exist because f of x is not equal to minus f of minus x. And f of x plus 2 equals f of x minus 2 is once again an incorrect representation because the constant here is x equals 2. So 2 plus x and 2 minus x are the x components on that graph. So option B is the right answer for this question asked in 2004. Let's look at the next question. The domain of the function fx equals sine inverse of x minus 3 divided by 9 minus x squared the whole root is, you need to find the interval which correctly represents the domain. So if you look at the function, f of x is having the numerator sine inverse of x minus 3 and the denominator is under root of 9 minus x squared. So basically, fx is of the form fp of x divided by q of x. So basically you have one function with respect to x divided by another function with respect to x. So therefore the domain of this function can be written as the domain of function p of x intersection with the domain of function q of x. Now let's look at each of these functions, p of x and q of x. So on comparing, you will get p of x is equal to sine inverse of x minus 3. Now, in the chapter inverse trigonometric functions, you will know that the domain of the sine inverse function is minus pi by 2 to pi by 2, and this is a closed interval. So therefore, you can write minus pi by 2 is less than or equal to the function p of x, that is sine inverse of x minus 3, which is less than or equal to pi by 2. So this is the general equation that we get. So from this general equation, how do we get the domain of x? So how do we get the value, the interval which represents the values of x, which is the domain? So what we do is we put sine function across that relation. So therefore it's sine of minus pi by 2 less than or equal to x minus 3 less than or equal to sine pi by 2. So therefore you get sine of minus pi by 2 as minus 1 less than or equal to x minus 3 less than or equal to sine of pi by 2, which is 1. Now what we do is we add 3 across this relation. So minus 1 plus 3 less than or equal to x minus 3 plus 3 less than or equal to 1 plus 3. So therefore minus 1 plus 3 is equal to 2 less than or equal to x minus 3 plus 3 is equal to x less than or equal to 1 plus 3 is equal to 4. So therefore, as you can see, 2 is less than or equal to x less than or equal to 4. So the interval here is closed interval 2 to 4, the interval for x. Now the other function, that is q of x, is under root of 9 minus x squared. So since the value of 9 minus x squared is under a root, in order to have real roots, 9 minus x squared has to be always greater than 0. So to have real and different roots, 9 minus x squared has to be greater than 0. So therefore you will get 9 as greater than x squared. So therefore x squared is less than 9. So therefore mod of x is less than 3. So if mod of x is less than 3, then you have minus 3 less than x less than 3 as the relation. So therefore you get an open interval of minus 3 to plus 3. So now we need to take the intersection of both of these domains. So that means you take the maximum, the highest of the first term and the lowest of the second term. So among the highest terms here, you have 2 as higher than minus 3. So you have closed interval of 2. And then the right side of this interval will be 3 because it's lesser than 4. So closed interval 2, open interval 3. This is the domain of the function f of x equals sine inverse of x minus 3 divided by under root of 9 minus x squared. So therefore, option B is the correct option. Now don't think that option C is correct, because here it is the closed interval for 3, which is incorrect because x is less than 3. It can never be equal to 3 according to the relation that we found out. So option B becomes the right option, and 1 and 2 are incorrect because the values are different. Let's look at this question. Let R be the relation of, now the relation is written as a set, so set of 3, 3, 6, 6, 9, 9, 12, 12, 6, 12, 3, 9, 3, 12, and 3, 6. Now this is a relation on the set A equals the set 3, 6, 9, 12. You need to find out whether the relation is reflexive and symmetric only, an equivalence relation, reflexive only, reflexive and transitive only. So therefore, you need to check whether this is reflexive, symmetric, or transitive, and accordingly choose one of the 4 options. The question was asked in 2005, and this uses the 3 properties of relations, whether it's reflexive, symmetric, or transitive. So the given relation R is 3, 3, 6, 6, 9, 9, 12, 12, 6, 12, 3, 9, 3, 12, and 3, 6. So in order to prove that a relation is reflexive, you need to prove that the element A, A belongs to R. So for all values of A, that is 3, 6, 9, and 12, you have an element A, A. 3, 3, 6, 6, 9, 9, 12, 12 are present in the relation. So since 3, 3 belongs to R, you can write that R is reflexive. So that means all the 4 options are viable at this stage. Let's look at whether this relation is symmetric. So for the relation to be symmetric, A, B belongs to R implies that B, A also belongs to R. So in the relation, we do have the term 3, 6 belongs to R. But if you look at the relation closely, there is no element called 6, 3. So the element 6, 3 does not belong to the relation R. So therefore, you can write that the relation R is not symmetric. So therefore, that rules out option A, option B. But still, you have option C and option D to take care of. So for that, you need to check transitivity of the function. So to prove that the relation. So to prove that a relation is transitive, you need to get the condition that A, B belongs to R and B, C belongs to R implies that A, C must belong to R. So if you look at this relation, you have 3, 6 belongs to R, 6, 12 belongs to R, and also 3, 12 belonging to R. So 3, 6 belongs to R, and 6, 12 belongs to R implies that 3, 12 also belongs to the relation R. So therefore, the relation R is transitive as well. So since it's reflexive and transitive, option D will be the correct option. So option D, reflexive and transitive only, is the correct option. Option C is incorrect because it says that the relation is not transitive, which is incorrect. And options A and B are incorrect because the relation is not symmetric. The relation given in the question is not symmetric, so therefore options A and B are incorrect. And since it's reflexive and transitive, option C also becomes incorrect. The most appropriate option is option D. This is the next question. Let f be a function from -1 to 1 to the set B. This is a function defined by fx equals tan inverse of 2x by 1 minus x squared. And the condition is given that f is both 1, 1 and on 2. We need to find out the interval B. So which interval of B gives us the function f of x equals tan inverse of 2x by 1 minus x squared as both a 1, 1 and an on 2 function. So in order to solve this question, let's take x to be equal to tan theta. So that means theta can be written as tan inverse x when the function is in terms of theta. So now f of x is 2x divided by 1 minus x squared, and this is under a tan inverse function. So now putting x as tan theta, you get tan inverse of 2 tan theta divided by 1 minus tan square theta. The terms which are inside the bracket are equal to tan of 2 theta. So therefore f of x can be written down as tan inverse of tan 2 theta. So tan and tan inverse functions get cancelled, so you have 2 theta as f of x. So therefore f of x can be written down as 2 tan inverse of x. So 2 tan inverse of x is the function f of x. Now the function f is both 1, 1 and on 2. So since it is 1, 1, since it's 1, 1 and on 2, then minus 1 will be less than x will be less than 1. So that will be the domain of the function. Now what we can do is we can apply 2 tan inverse on all of these sides. So therefore what you get is 2 tan inverse of minus 1 less than 2 tan inverse x less than 2 tan inverse 1. So 2 tan inverse of minus 1 is 2 of minus pi by 4 less than 2 tan inverse x less than 2 tan inverse of 1 is 2 of pi by 4. So therefore minus pi by 2 less than 2 tan inverse x less than pi by 2. So 2 tan inverse x can be written as f of x. So minus pi by 2 less than f of x less than pi by 2. So according to this, option C is the correct option. So since minus pi by 2 is less than f of x less than pi by 2, so therefore option C, that is the open interval, will be the correct option. The option D is incorrect because it shows closed interval, where in fact the interval here is open. And 0 to pi by 2 is not the interval. The interval is from minus pi by 2 to pi by 2, as demonstrated when we solved the question. The question is once again from 2005. Now we move on to the final question of this episode. A function is matched below against an interval where it is supposed to be increasing. Which of the following pairs here is incorrectly matched? The interval 2 to infinity to the function 2x cubed minus 3x squared minus 12x plus 6. Option B, minus infinity to infinity, the open interval from x cubed minus 3x squared plus 3x plus 3. Then in option C, the interval open interval minus infinity to closed interval minus 4 belongs to the function x cubed plus 6x squared plus 6. And option D, the interval minus infinity to 1 by 3, closed interval, to the function 3x squared minus 2x plus 1. So here the condition is that the function is supposed to be increasing. One of these is not increasing, so therefore that pair is incorrect. So for this question in 2005, we need to solve everything and we need to find out which of these is the correct one. So how do you solve the question? So let's take each option. So option A. In option A, the function f of x is equal to 2x cubed minus 3x squared minus 12x plus 6. So the first step is differentiate. So on differentiation, you get f dash x as equal to 2 times 3x squared, so that is 6x squared, minus 3 times 2 of x, that is 6 of x, plus minus 12 times of x, so that is minus 12. So when you take 6 common, you get x squared minus x minus 2. So that is 6 times x squared minus 2x plus x minus 2. And what you're essentially doing is splitting the middle term, so that is x into x minus 2 plus 1 into x minus 2. So basically 6 times x plus 1 times x minus 2 is the differential of the function f of x. So since the function is increasing, the value of f dash x must always be greater than 0. So therefore you have 6 times x plus 1 times x minus 2 as greater than 0. So that means x plus 1 is greater than 0, so that means x is greater than minus 1. X minus 2 is greater than 0, so x is greater than 2. So if you look at the question, closed interval 2 to infinity will give you the function 2x cubed minus 3x squared minus 12x plus 6 as an increasing function. So therefore, the question is to find out the incorrect pair. So since this pair is correct, option A is incorrect. Let's look at option B. So in option B, you have f of x equals x cubed minus 3x squared plus 3x plus 3. Now let's do the other options a little bit quickly so that you get their answers. So you're differentiating, so x cubed is 3x squared, minus 3x squared is 6x, and then you have plus 3. So therefore when you take 3 out, you have x squared minus 2x plus 1. X squared minus 2x plus 1 can be written down as x minus 1 the whole square. So therefore, since the function is increasing, you have 3 times x minus 1 the whole square as greater than 0. So that means x minus 1 must be greater than 0, so x is greater than 1. And since it's under a square, then at any point on the interval minus infinity to infinity, so instead of checking this out, what you can see is that x minus 1 is under a square. So whether you have positive values of x or negative values of x, you will have the correct interval, that is minus infinity to infinity. So even if you have an interval minus infinity to infinity, and even if it's open or closed, the function will still be increasing because you have a square term in its differential. So therefore this function is increasing and its domain is and the interval is correct. So therefore option B is incorrect. Now let's look at option C. In option C, the function f of x is equal to x cubed plus 6x squared plus 6. So therefore the differential here is 3x squared plus 6x. I mean, not 6x, it'll be 6 times 2x. So that is 12x. So it'll be 3 times x squared plus 4x. So that means you can write 3x times x plus 4 as the differential of this function. So as function is increasing, that means 3x times x plus 4 is greater than 0. So that means x is greater than 0, x plus 4 is greater than 0, so x is less than of minus 4. So therefore what you get is the fact that x will be less than minus 4, so therefore the correct interval will be minus infinity, open interval minus infinity to closed interval minus 4. So at this point the function here is an increasing function. So therefore, option C is also correctly matched, so it is an incorrect option. So now you know that A, B, C are incorrect, so that automatically means D is correct. But let's prove why D is correct. So once again, it's the same step. F of x is equal to 3x squared minus 2x plus 1. Taking the differential, you have f dash of x is equal to 6x minus 2. That is 2 times of 3x minus 1. Or instead of taking that, what we can do is we can take, since the function is increasing, you can just take 6x minus 2 directly as greater than 0. So 6x is greater than 2, x is greater than 2 by 6, and x, so that means x is greater than 1 by 3. So according to the differential, as the function increases, x must always be greater than 1 by 3. But if you take the interval here, which is open interval minus infinity to 1 by closed interval 1 by 3, you find that the interval gives you the decreasing function for f of x. So that means the interval and the function are not correctly matched for the condition that fx is increasing. So therefore option D is the correct option for this question. So that concludes this episode of JEE Main. For more of our videos on such relations and functions, you can always hit the link in the description down below. For accessing more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next episode, take care, stay safe, bye-bye for now.